Okay.
We are all such nerds.
Testing.
Love it.
I'm Arjun. Nice to meet you, Nick.
Okay, let's introduce ourselves to each other first before we start arguing. Hey guys, I think I've met everyone. Maybe we met.
I don't think we have. Noah, nice to meet you.
Daniel, good to meet you. Okay, so I'm Daniel, co-founder and COO here at OneBalance. I'm sure you all know what it is that we're doing, or at least I hope you do, because we've been talking about it a lot today. We initially, I guess, we have this panel named as Superchain versus chain abstraction. We don't actually have anyone specifically from like Optimism here. We do have, I guess, Inc. Building on the OP stack. So I thought it would be good to kind of generalize this out a little bit to like, I guess, intra-cluster interop to kind of account for like Superchain, ZK Sync's solution, Polygon Ag Layer, Arbitrum solution, and kind of think about L2 interop between like families of chains and verse chain abstraction. I mean, we can just, that's a bit of a mouthful, so we can just say Superchain, but when we say that, let's kind of assume we're talking about like any interop between like L2s, just to keep things simple. So I think it would be good to kind of gauge our audience here. Like, I want to understand who's more familiar with the kind of L2 interop side of things versus who's more familiar with like chain abstraction and some of the solutions that we're kind of looking at there. So if we can get a show of hands, who would say that they're more familiar with the L2 and the interop side of things? Okay, maybe half, slightly under half. And who would be more familiar with chain abstraction and the solutions being built there? Just over half, but let's say half-half. Okay, that's good. It means we have like a nice balance of understanding. Yeah, we could divide up the room and you can argue with each other and like fight at the end maybe. I'm definitely more experienced in chain abstraction, still learning a lot about like Superchain and interop, so maybe I'm gonna ask dumb questions. If I do, half the room's gonna learn and the other half is just gonna think I'm an idiot, but that's fine. Okay, maybe we can start off with like a quick introduction, like a few sentences on like who you are, what you're building, and kind of how it relates to either chain abstraction or Superchain. Let's just go along the road, but I promise we're not going to like just ask questions and have like everyone answer them one at a time. We're going to like try to be a little bit more dynamic, and like if people in the audience have questions that they want to like they're itching to ask, put your hands up. We can like dive backwards and forwards between the audience again throughout the presentation as well. But not yet. You got to wait. Give us like 5 minutes first. Anyway, let's kick it off.
Hey guys, my name is Bo. I'm a technical co-founder at Polymer. We're working on a real-time interoperability solution for cross-rollup communication.
Hey, I'm Arjun. I'm one of the founders of Everclear. Everclear coordinates the settlement of intent solver liquidity between chains. We were one of the first like intent-based bridges back when we were formerly known as Connext. Not one of, we were the first intent-based bridge. And then we were also the people that kind of like kicked off this whole like chain abstraction movement and vision.
Yeah, so I'm Nick Paterno. I'm at Inc., Kraken's new L2. I'm actually not Nick Pease. You might be able to tell. That's our CSO, definitely not me. Yeah.
Hey everybody, I'm Noah. I'm CEO and co-founder of Nodekit. At Nodekit, we're building out the first super builder, and we're building out the first super to bring composability to chains.
So of the panelists here, who would say they're kind of more knowledgeable and focused on chain abstraction, and who versus like the Superchain? Let's go chain abstraction first. I mean, you guys talked about chain abstraction before it was sexy, right? I remember seeing like a blog post when we started talking about chain abstraction, and we were like, oh shit, these guys were here first, but let's not talk about that. I guess everyone else is more in the Superchain side of things. Okay, quick question. How would each of you define like Superchain and chain abstraction, and what specific problems are each of them trying to solve? Let's go backwards this time.
Yeah, I think that Superchain or any like rollup cluster interoperability protocol is really trying to solve this issue of we're going to have a lot of these different rollups. How are we going to connect all of them in the most seamless possible manner? I think chain abstraction serves as a great front end for that. So I would section chain abstraction as anything at like wallet level upwards, and I would section everything under that as being more so rollup interoperability protocols. That's how I view it.
Cool, yeah, I would define Superchain as sort of a network of chains that share standardized code interfaces, standardized security audits, and share their network security. As far as chain abstraction, I would define that as sort of an approach to sort of abstract away some of the complexities of interchain communication.
Yeah. So maybe we can get into this later. I personally think that these two things are really the same thing technically. It's just more around like where they're applied, and in fact, both can coexist. And I'm sure we'll end up getting to that over the course of this conversation. But at the highest level, I think definitionally, chain abstraction is like more of a vision and outcome of like users should not have to care what chain they're on, right? Which just makes sense. As a user, you don't want to have to understand how Google's like distributed systems infrastructure works when you're using YouTube. And then I think the superchain is sort of like a more narrowly scoped thing, which is let's find a way to optimize the different kinds of interoperability that we can have within an ecosystem where we can control every aspect of an implementation of a rollup, right? And because you have this like hack of like I can do whatever I want on this, you can do interoperability in a much more sophisticated way.
I'll piggyback off of Arjun's point. I think chain abstraction is strictly a superset of interop, and especially interop within clusters. You can abstract over clusters. Clusters are groupings of individual rollups.
Yeah, I think I'd tend to sort of land on the superset of interop. You mentioned they're kind of the same thing, and I guess how are they the same thing in a world where we have like Bitcoin and Solana as well, and we're trying to like abstract all chains? Like, is it really fair to say that they're the same thing in that case?
So the reason that I say that they're the same thing is that like, okay, wait, who here likes distributed systems? Awesome, love that. This is a very great audience for this then. And I'm sure everybody from OneBalance will love this. It's all resource locks.
It is.
It is. It's all resource locks, right? And ultimately, it comes down to like if you're building a distributed system, and especially more complex distributed systems, right? Like, what you're trying to do is figure out how you can make concurrent updates to some shared state. And that's like you're doing that either in like cross rollup interoperability within a cluster or outside of a cluster, and then also like how that rollup is making concurrently like ordering those updates when it posts batches to Ethereum, right? And there's like two ways to do this in traditional distributed systems. There's many other ways too, CRDTs and stuff like that, but there's two ways that are commonly used in distributed systems. There's optimistic locking, and then there's pessimistic locking, which isn't really called pessimistic locking, but yeah, basically pessimistic locking. Optimistic locking is when you say, I'm going to just go attempt to make a change to this resource, and if it works, it works, and if it doesn't work, I'm just going to drop it. And that is intense, right? I'm going to attempt in the lightest way possible to just go and update the state on this other chain, and like, if that state can be updated because there is enough liquidity and because that state update is valid and things like that, and because the state at the time of the transaction execution is able to be updated in a way that's like compliant with the state machine, then it will happen. And if it doesn't, it won't happen, and it's fine. Whereas shared sequencing is more of a pessimistic paradigm where you have to actually acquire a lock, which means acquire a shared block between rollups, make an update in that block or a set of updates that are all ordered, and then release that lock by basically ordering that block against a bunch of the other blocks that are happening.
So I guess the fact that you need to like acquire these blocks or these locks first really shows that this is less about usability and more about like communication between chains, and like the kind of chain abstraction solutions like around resource locks and kind of solver-based intent execution is more on the kind of usability side, and perhaps the other use cases are on the kind of interop side. And I guess following on from that, like what are some use cases that you think are superior in a world of like intra-chain interop? So say, like we sort of see that a lot of the bridging today is happening through like intent-based bridges like across. And most of the activity that is kind of occurring on Ethereum and kind of blockchains today is like value transfer and like swaps and things like that. So what are the biggest use cases of this like inter-chain interop that can't be solved with like chain abstracted intent-based solver-based systems? Feel free to anyone jump in here.
Yeah, I think that could be solved with systems such as this. Is like the simplest case is just being able to accept deposits from anywhere, any different chain. You can accept deposits on it from any other chain, and that really allows applications to expand out their TAM with that. So I think that's one of the first things that like interoperability can really help with.
Why can't you do that with like
I think you can do it with chain abstraction, but I would say that you can get better guarantees around it. I would say that you have better guarantees around MSC either at the time of settlement or at the time of execution. when you have essentially an inter-rollup cluster communication around it.
So,
But
how does latency fit in here? If you're sort of waiting for, first you have to get some kind of lock or some sequencing on the chain before you can execute this. Like maybe you have better atomicity, but do you really have a better user experience? Is it really better for depositing funds if you?
So is the question here which inter-rollup interoperability you can do that you can't do with chain abstraction then?
That was the first question, and now I guess having a follow-on question and asking a little bit more. Why is depositing from any chain or depositing from other chains better with this versus an intent-based system? I guess I'm not completely convinced on that.
Or maybe you're asking basically what are the trade-offs of one approach versus the other?
Yeah, I guess that's what I'm asking.
Yeah, I don't view them as necessarily competitive solutions. I view them more as additive. I think that the stuff that we're building on Nodekit with super builders allows for atomicity across chains, and I think that really pairs well and nicely with chain abstraction because it allows chain abstraction solutions to decrease risk when they're able to take essentially atomic bundles across multiple chains. So I would say anything that is chain abstracted is better if you can have atomicity in it.
I agree with that. Any other thoughts?
I mean, I definitely agree. Maybe a bit of a hot take here, but I fundamentally disagree with the sort of superchain versus chain abstraction premise. I think they are complementary. I think the underlying, solver and resolver networks will utilize the interop bridges whenever they can, whenever it makes it most efficient. So I think they are highly complementary.
Well, without the versus framing, this wouldn't be a spicy panel. So.
I also didn't name this panel, so don't blame me.
I think intent-based systems, resource locks are very useful in cross-cluster communication. If you want to go quickly between clusters, you are taking on some risk. And when you want to offload this risk to a solver-based system, I think that makes a lot of sense. Within a cluster, though, some of this risk is, taken away by having shared settlement. So you can, the way I like to think about cross-rollup interactions is creating edges in a graph. And then you can have these edges either pessimistically validated or optimistically validated. And within a cluster, if you share settlement, at settlement time, these edges will be validated. So within a cluster, you can pretty much have intra-block communication super fast. You don't need to necessarily validate these edges up front. And there's no additional risk taken. So I think the solver-based system within a cluster, the argument's a little bit weaker than between these clusters, where if you want to go super fast, you have to pessimistically validate, and you have to have some trust assumptions beyond that of the settlement layer.
You kind of answered one of the follow-up questions I had. No, that's good. No, it's good. It's a good segue. That was about what is the role of resource locks in a kind of superchain world, or in a world where people are trying to move value between these different clusters of superchains?
Yeah, I mean, I think that just kind of building on top of what Bo said, I guess it's important to kind of think about what are the limitations of superchain style atomic cross-rollup interoperability, right? Obviously it is the ideal outcome from a state update perspective, where when you have atomic inclusion of an update, it's basically the same as being on the same chain, right? So you can do stuff like flash loans that is otherwise not possible because otherwise has to be executed over multiple blocks. And that's extremely ideal, but unfortunately with blockchains, anytime you get anything that's extremely ideal, you're always really taking the L somewhere else. And in this case, it's an interesting question because I think there hasn't been enough discourse around what are going to be the limitations of shared sequencing. So shared sequencing seems to work really effectively when you have a small number of rollups and you're one shared sequencer is able to run all of those rollups, and then shared sequence every block, because then effectively every single block you can just do atomic updates between all of them. But then that breaks down when you start talking about many more rollups, right? This is for instance the issue with the base sequencing paradigm, where it's it works for 6 to 10 rollups, and then when you start to talk about hundreds of rollups, well, only the 6 to 10 rollups are actually going to get shared sequence and everybody else is not. And so then that creates this new paradigm, which is in reality, when you want to get a shared block, you're probably going to have to wait for it, right? If on anything other than the biggest rollups, you're going to have to pay for that in some way, either by putting up a larger amount of funds in order to get that shared block to get some builder to go in and put them together, or just wait until it's convenient for someone to do it. And I think that that's kind of where maybe this trade-off space lies, which is if you're trying to create an experience where you just want to like have someone be able to deposit into your app and onboard in like at web scale, right, milliseconds ideally, then you don't want to have to deal with the complexity of like potentially waiting for lock acquisition. You just want to make sure that it happens as fast as possible. But if what you want is to do this like more complex operation where you're updating state on multiple chains at the same time because your state lives on multiple chains. So for example, a flash loan is a really good example of this, a good instance of this where you're updating state here and here at the same time and they must happen at the same time, then it's probably worthwhile for you to pay for and wait for that lock.
Yeah, I would also like to add on that. I think that shared sequencing by itself, as well as like super builders in general, I would say that we're most likely going to see collaborative block building. I think that it looks very similar to Intents. We've already seen this. We're currently sitting at right around 18 chains that we're working with. We've already seen that there will indeed most likely be some scaling issues close in the future, even running across multiple machines. So we anticipate seeing sub-auctions essentially live on top of our system, where one builder might sell out the rights to build 3 or 4 other roll-up blocks and have one builder that goes and specializes and does that. So we view block building as very similar to the Intents paradigm, where you have different specialized actors, and you see the same thing with Intents being collaborative solving.
How do, actually, it's really, really interesting. This is the first time I'm hearing about this. So marketization of block building, I think, makes a lot of sense. But the collaboration part is what I'm kind of, like my main question around the collaboration part is how does a block builder trust the state update of another block builder without verifying the other set of rollups?
Yes, so I would say one block builder doesn't necessarily need to trust the other block builder. In this case, what they would need to be able to do is assign risk out to the other builder. So each builder in this case is staked. So if each builder is staked, and let's say you have a mapping of all of the rollups and who built the blocks and who signed off the blocks for each rollup, then it would be as simple as saying, Bo's key signed off on these 3 rollups, my key signed off on these 3 rollups, and I transferred Bo over eligibility on these 3 rollups.
So what are the kind of risks?
Delegation.
So in these systems, like in these interop, I guess, like intra and intercluster interop systems, what are the risks that exist? So we know when we're looking at like intent-based solver sort of chain abstraction solutions that generally the risk is carried by the solvers who are like sophisticated actors. They're very like qualified and have a lot of expertise in like pricing this risk. What risks exist in the kind of interop world?
It's kind of the exact same actors. It's the exact same market makers are doing building as well as doing solving. So I would say it's pretty much the exact same actors are pricing risk in this, and they're all staked as a result and get slashed if they have a fault in this case. So it's pretty similar.
I think the definition in my mind for a rollup cluster is not necessarily whether it's a single shared sequencer. I know Noah and I may not agree on this. In my mind, it's whether rollups share a settlement layer or settlement layer and settlement bridge. Either the settlement mechanism is chained together, or it's the same bridge contract. In this mode, if it's rollups that are split across maybe like even 10 shared sequencers, it wouldn't necessarily matter if let's say they didn't really like pessimistically validate the edge, because whatever weak security formed by the pessimistically validated edges eventually will be validated at settlement time. So there's no risk that's carried in this kind of system. The risk is only when you're going across rollups that don't share settlement together. And then in that case, like the application is the one taking the risk.
I guess if they are like not sharing the same sequences but all checking into the same L1, is there not a risk where you can have a reorg on like the transaction that's coming from the origin chain, and then the transaction on the destination chain has already been fulfilled, someone's gone and spent that balance, and then that reorg like rugs that transaction? Doesn't this result in like the risk of kind of cascading reorgs throughout this system?
Yes, I would say that the way that we viewed risk thus far is that you need to have some form of like a watchtower system eventually in this to allow to avoid cascading reorgs, as well as having all the actors within the system need to be staked a certain amount. So it's similar to how bridges have to handle the risk around it, I would say.
Yeah, it's like the unfortunate so the fortunate outcome of this is that if you're using a shared bridge and a shared settlement contract, then like you could do whatever you want. You can roll back anything. You can just arbitrarily propose some state, and like it's fine. It's just more of a matter of figuring out whose fault it is. I think in practice, figuring out how to do that is going to be quite interesting for like an unbounded set of rollups.
Yeah, for us, I would say the way that we've thought about it thus far is that there's going to be a variety of different state proof mechanisms that you need to prove to on-chain contracts in order to slash the builder as a result.
Yeah.
The main difficulty will be around paying out users in the case of a fault.
Yeah, so the example that I'm kind of concerned about would be something like a conditional airdrop, where you're saying on a certain chain, provided certain conditions are met, distribute tokens to like players across all of these different chains, and then you're doing that in a single shared block. And like, I assume that this is sort of something that would be like collaboratively built, right? Like you would want this to be collaboratively built across all rollups. But if there was a fault somewhere where some people are relying on like a certain subset of rollups that is being sequenced, there's this like contagion effect that it kind of hits everybody, which is weird.
Well, in this case, are you saying that a few of the rollups don't execute the transactions when you want to have an atomic bundle hit like all of the rollups at once?
Exactly. Like you kind of end up in this weird.
It'd be caught in SIM then, most likely. Unless the chain went down unless you had 3 chains that went down at the time of an atomic bundle, builders are simulating state before they're including these bundles.
But isn't it fine if they share the same settlement contract? Because like you're going to have some like short-term inconsistencies with eventual consistency at some point. So the only real danger is if you go from this cluster to another based on this initially inconsistent data, or if an on and off ramp allows you to off ramp based on this invalid but later to be invalidated state.
It's fine, but whoever is doing pre-conf is going to have a nightmare.
Not our problem. Someone else.
Exactly. Yeah. Espresso.
Wait, why does a pre-confer have a issue?
Because basically, like, yeah, like if you have a shared settlement contract, then like I said, you can post any state to it, right? You can undo whatever state history you want, but anybody that is relying on that state history externally from outside of this cluster needs to figure out how to like deal with that. And the only instance that you would do that is if like a pre-confer actually attested it. And so whoever's running that infrastructure is going to have to be like really aggressively making sure that there's no risk of contagion rollbacks. Yeah.
That's why it needs to be run by sophisticated actors, and we anticipate that there will be more central. We view it. Vitalik actually put out something a couple of years back. The Mega people cited the post, but there's actually a second part of it, which is having centralized block production, decentralized validation.
Endgame, right?
Yes. And I would say that that's what we view super builders to look like, where there's centralized block production amongst a few different entities, and then there is decentralized validation for these systems.
So in this case of like a super builder that is building blocks for like multiple chains, say you have like a super builder that's building blocks for like 5 different like OP stack chains.
Yep.
How do you think about sovereignty of the chains in this case? Like, does the chain inherently lose its sovereignty if it is outsourcing its block production and like sharing all of the same security models, all of the same update requirements that like all of these other sequences like have, because it all happens to happen at the same time? Like, is this?
Yeah, I would say that they're not necessarily sharing the same block times with us. The way that we've designed our system is it's a shared auction that happens 12 seconds in advance, so they don't have to share the same block times. They don't have to necessarily give up the sequencing fees and change the Coinbase to this address as well. So I'd say they do give up sovereignty around delegating to an external builder, but it's a lot less sovereignty than I would say other solutions require.
We haven't really precisely defined what sovereignty is in the context of a rollup, and I think we all talk about it. I talk about it all the time, and like we say like, oh well, there's plenty of beneficial aspects to sovereignty, and there are like certain features. Mark, this is I think an interesting question for Inc. Like, what aspects of sovereignty did you guys care about? Was block building a part of that?
Yeah, I mean, we ultimately want to decentralize the block builder. We do care, about, enabling, essentially giving Inc Chain to the world, if you will. I think it's maybe a bit of a false dichotomy, potentially. I think you gain a lot from, if you imagine like TCP/IP, for example, just because you have standardization on the protocol doesn't mean you necessarily give up centralization or control over the underlying protocols. So we think, the Superchain is sort of that type of a situation.
I guess I was previously at Flashbot, so maybe I'm a bit of an ordering maxi when it comes to like what's important in terms of like value capture for chains. And it seems like it seems, I guess, like intuitive that a chain that has a lot of like value transacted, there would be a lot of value in controlling the ordering of like those transactions on the chain. And if you're, Uniswap chain and you want to like monetize the order flow, like one way of doing that would be to control the ordering. And do you kind of give this up in a Superchain world? I guess, Nick, like, is this something that, I guess, kind of following on from your question, is this something that you've thought about when like building Ink, and you've thought about the importance at all of ordering, or this has not been top of mind in this decision?
Yeah, right now, it is going to be a centralized sequencer. And so, one of the, early things that we were thinking about is just sort of protecting users from MEV and sort of different ordering attacks and stuff like that. We've considered a lot. There's still some things, because mainnet still hasn't launched yet that I can't really get into. But
Alpha.
yeah, I'm gonna get in trouble.
Can't tell you what the alpha is, but there is alpha there.
Announcement of an announcement, guys.
How long do we have left? 5 minutes? Cool. Do we have any questions from the audience? Spicy questions? Or we have Euclid.
Yeah, there was a... Oh. Hello.
Hello.
Pre-conf was briefly touched upon by Arjun. A question to the panel. Do resource locks eliminate the need for pre-conf?
They're the same thing. It's just a different actor. It's somebody giving a resource lock on something. It's just block space instead of an account. So,
like, to follow on from that, from projects that specialize in pre-conf, do we just eliminate them?
I would kind of disagree. I wouldn't say that it's like a lock. I would say it's more like insurance on the lock, right? It's sort of like okay, you have agreed to lock this resource, but the reality is it's on a roll-up and no one's posted an update or anything. So really that agreement just means nothing. Really, it means absolutely nothing, right? And at some point in the future, that agreement will be viable, but right now it doesn't mean anything at all. And so what we're going to do is we're going to ensure that agreement such that if it happens to not mean anything at all and happens to be incorrect, then you'll get paid out.
I was assuming we were talking about based roll-up pre-comps, like based pre-comps.
Oh.
Which that's the same as a resource.
Actually, that's a good question. Is it?
Are
you talking about in the base sense or in the like?
More ETH L1
Then that's
rather
based.
than roll-up.
Okay. Yeah, in that case, it's the same thing.
Nathan.
I want to ask if we're using centralization to make interop artificially cheap at the moment. Seems like we often want interop to happen really quickly, and like normally this would be like quite expensive to have guarantees around. So we just use centralization to make it cheaper, and we could run into all kinds of problems in the future. We're like, okay, we need to have guarantees around liveness and decentralization here. Is it going to get a lot more expensive when we do that? Is that kind of like the incoming wall for interop?
I don't necessarily know if it gets more expensive. I think that the bet that we're making is that there will be more usage over time, and that if we build a system that's successful, it will be profitable for other actors within the system to run these machines. So I would say that that's how we viewed it thus far, is that if you build something and you build a system right in crypto, you shouldn't necessarily need token subsidies forever and ever to run the system. People should run it because they make money on fees, and it could be a profitable business.
We touched upon it in the beginning, where within a single cluster, you can essentially do no validation. So if OP sends a message within their Superchain native interop spec, you're not actually validating the message in the VM. No proof is supplied. They're optimistically sending these messages to be later validated. So that's pretty cheap, pretty fast, and eventually secure. And there's like kind of trade-offs here, of course.
I want to add to this from the perspective of like interop protocols separately outside of like intra-cluster. To answer your question, are we artificially reducing the price of interop by centralizing things? Absolutely. Like, this is the reason why intents exist. Intents are like the L2 of interop, right? Like, they are. Like, they're the L2 of interop because, like, what do rollups do? They take a bunch of updates, they batch them all together, and then you post a single batch update to Ethereum because it's too expensive to compute like state updates, all of those state updates on Ethereum directly. That's effectively what an intent is, right? You're rehypothecating this like n-party system where you were, in theory, supposed to be validating a state transition that happens from here to here using something like a light client or using, a storage proof. It's using something that is actually quite expensive. And you're rehypothecating that by saying like, okay, we're just going to make all of these like fast one-to-one interactions happen, and then we're just going to post a batched update to the underlying interoperability layer. Right now, none of the like message transport protocols are actually using light clients. Those light clients exist, by the way. The reason that they're not using light clients is because in order to use light clients, even for like sending, I think it was like, I saw some like metrics around this. So sending one message every like 15 minutes costs like several $1 million a year. And so when you're talking about like, oh, we're using a messaging protocol that's doing like, I don't know, thousands of TPS, that's just not viable, right? That's why you need some amount of batching. Security is expensive. Like the same problems exist with interop as have existed with L1. Like the scalability trilemma of blockchains is exactly the same thing as the interoperability trilemma of bridges.
Arjun, I'm stealing that quote.
Okay, we've got 1 minute left. Do we have any final questions from the audience? Yes, the good-looking gentleman back there.
If we're allowed to ask spicy questions, I guess this
Encouraged.
is more tailored towards Nick than anyone else.
All right, send it.
Why
Send it.
OP superchains instead of Arbitrum, Nova, and Orbit, or ZK and their vision? Why OP?
Yeah, we explored basically all of them. We had internal test nets for over a year before we decided on OP. We just like we view it as sort of just thought, right? It's the sum of the whole is greater than the sum of the parts. There's the standardization. You get shared security, of course. You get shared auditing. You get the ecosystem that comes with it. OP is the biggest L2 stack out there. They are winning all the market share in our opinion. OP isn't fundamentally opposed, for example, to ZK proofs. You could always add that on down the line. In fact, I believe the research is heading that way. So there's just a lot of benefits that we saw to the OP stack that outweighed everything else.
And then a quick follow-up. I know it's only going to take 10 seconds to the rest. If you could if you're making a brand new project and it's its own chain, which one would you choose? OP stack, Arbitrum, or ZK?
Yeah, I would choose OP stack.
There's evidence of that.
OP stack, I think that it's the simplest to understand. I think that I've seen some of the other code bases and they get a bit hairy, to say the least. So I would say that that's my personal favorite in development timeline.
So we have a rollup. Everclear is a rollup. A lot of people don't know that. And Everclear is an Orbit rollup. When we chose Orbit as our stack, this was like start of this year, we chose it because of the 250 millisecond block time, which is actually super important for some of the stuff that we're doing. I would say, and then there was a couple of other reasons as well. I would say, generally speaking, that gap has just really narrowed. So like now I would have a really hard time making a decision, and the decision would likely be based off of non-technical things and more based off of like what support are we getting from the ecosystem, what relationships do we have, potentially interoperability with Superchain, potentially other things.
We're building on the OP stack, so we're biased. We have a OP Cosmos implementation, so it's not OP Geth. We're the first Cosmos rollup on Ethereum.
Wow, maybe we should have kept the panel as Superchain versus chain abstraction. Everyone's so bullish on OP here. Okay, that's about time. Massive thanks to all of our panelists here. Please give them a round of applause.
Thank you.
Thank you.